This lesson is for Advanced Algebra 5-2 on solving systems with tables and graphs. First of all, a system, not a solar system, but a system of equations is when you're working with more than one equation or inequality at a time. It's important for students to keep in mind that there may be more than one solution when they're solving. We're going to be working with lots of different methods for solving systems. Today's methods are going to focus on using tables and graphs, mostly graphs. When students come across questions in the homework that ask them to use the solve command on their CAS, they're more than welcome to do that as a way to check their answer, but students, you need to know that when you're solving, you will be solving using either a table or a graph. You won't simply just type in the solve command. So that's what is happening on the lesson, the questions here that I have you skip. 3A, 4B, II, and 5C, those are all solve on the CAS. You should always solve those by hand. You may also skip question number 19, which is a matrix question from chapter 4, which we skipped. So a system is always going to have a bracket off to the side and multiple equations or inequalities. We're going to focus first on solving by graphing. When you solve by graphing, you simply find where the lines cross or intersect. So if we're going to graph by hand, we want those equations to be in slope-intercept form, and luckily they are. So we're going to go ahead and draw a graph. And I know that I'm going to need some significant room here on the x-axis, so that's why I made that a little bit longer. On our first equation, I know that the value without the x is the b value, or the y-intercept. So I'm going to put a dot at 3. Then using the slope as rise over run, the top number is negative, so I'm going to do 1 down, and the 2 is a left and right, so that's going to go to the right. So from my dot, I'm going to go 1 down, 2 to the right. 1 down, 2 to the right. Now if I do one more coordinate here, I'll be on the x-axis, which is a nice thing to do because then you'll know where the x-intercept will be. And a lot of times that is an important point to have, so let's go ahead and do one more point. Down 1 over 2. And then connect those with a straight line. Let's do the other coordinate, or the other equation. That one has a y-intercept at -4. And a slope of 2/3. Remember, rise over run. So the rise is 2, so I'm going to go up 2 and to the right 3. And I'm going to do that again. And look what happened. I ended up on the same coordinate that I had before, so I know that that is indeed where they cross. So my solution to my system is the coordinate 6, 0. So I could either give it as a coordinate like I did here, or I could list each value separately. But know that there are two answers here, an x value and a y value. Let's try another one, this time on the calculator. I'm going to type in 1/2 x minus 5 and 2x minus 1 as two separate equations. So I'm going to open up a new calculator document, a new graphing document on my calculator, and I'm going to type in 0.5x minus 5. And I hit enter and I get my equation. To get my equation line back, I hit the tab key, and I'm going to type in 2x minus 1. And when I type that, I get my other line. I can see that they are indeed crossing, but it's kind of hard for me to tell where exactly, so I'm going to maneuver my window down a little bit. To change the window, you go to Menu, Window, Window Settings. I want to go further down, so I'm going to make the y-min a larger number, a -10 or -12. So now I can see where they cross. I'm going to get the calculator to generate the actual intersecting point where they cross rather than estimating it by eyeballing it on the graph. To get the calculator to find the intersection for me, I go to Menu, Analyze Graph, and I'm going to choose Intersection. You'll see that it asks you for the lower bound. What that means is you want to move your cursor so that you're somewhere to the left of that intersecting point. Keep in mind that there are times when you have more than one intersection, and so the calculator is simply asking you to kind of narrow down for it where that intersection is located. So here I am definitely to the left, so I'm going to hit my line. Then I want to go to the right and click again, and now it gives me where my intersecting point is. negative 2.67, and negative 6.33. So I'm going to draw a quick sketch. Whenever you do your calculating on the calculator or your graph on the calculator, make sure that you put a box around it. And I'm going to just take another quick peek at my picture here. And so I've got a graph kind of looking like that. And again, my coordinate where they intersected was negative 2.67 and negative 6.33. And so that's my solution. So let's do a quick rundown of how we did that on the calculator. We graphed, and then we chose Menu, Analyze Graph, and then we chose Intersection. After we chose intersection, it asked us for the lower bound, and for that we went to the left of the intersecting point. Then it asked us for the upper bound, and for the upper bound we clicked to the right of where they intersected, and then it told us where that coordinate was. When you're solving with a table, on the TI Nspire calculator, we're going to start with a spreadsheet and we're going to switch it into a function table. Keep in mind that there are some settings that you might be needing to change. So we're going to utilize that same system of 1/2 x minus 5 and 2x minus 1. So we're going to utilize those same functions, and these are some of the steps that you're going to need in order to do a table. So you're going to open up your spreadsheet, and I'll demonstrate this once we've got the directions listed out here. So type in your spreadsheet, or open up a new spreadsheet document, and then you're going to do Menu, Table, and you're going to tell the calculator to switch to table. And I believe when you do this command, that'll be the only command available. So that'll be an easy one. Once you switch to the table, you need to select your functions. And this part's a little bit tricky, so I'll show students how to do that. Keep in mind that you'll want to have graphed them already. Graphed them before. So we've already graphed those equations. Once those equations have been graphed, even if we don't see the graph itself, those functions are now pre-programmed into the calculator, and it'll know that those are there, and those functions will be waiting for us when we get to the spreadsheet. So we're going to select our functions, and then know that you may need to go into edit the settings, and to do that you do Menu, Table again, and you're going to edit table settings. When you get into the table settings, you've got two options. You can tell it where to start, but the more important of the two is you're going to tell it how to step. What they mean there is what increments are you using to get from one value to the next. So let's go to our calculator again and do the table. So open up a new spreadsheet, and then we're going to choose Menu. And by the way, to get to that, you're going to want to, if you're on your graph here, hit a Control-I to get a new tab, and then choose Spreadsheet. Now we're going to do Menu, Table. Switch to table is our only choice. When you do that, you should see two little drop downs show up. So I'm going to choose F1, and it populates that table now with that equation or that function. To get the other function, just tap to the right or in this gray area again. You'll get your little drop down. Choose F2. So now what do we look for? We want to look for where the y values here are the same. The x values are predetermined for us. We just need to scroll up and down to be able to see the values and how they change. Now I know from doing this question already that the x value needs to be a negative 2 point something, so I'm going to try to look back here. As I look at negative 2, I can kind of see what's happening, and that as the first function is increasing, so is the second, but they're kind of increasing at different rates. If you look at the difference between these two, these are 4 apart, and now we're only 1.5 apart. Now we're only 1 apart from each other. Now we're only 1/2 apart from each other, and now we're up to 2. So they're starting to become the same right in this region. But my increment for my x's are only going by ones, so I'm not getting as accurate of a reading in my table as I would like. So I'm going to change the settings. Menu, Table, Edit Table Settings. And I don't really care where I start. I know I'm going to need to start in the negatives for sure, so I'm just going to leave that one alone. But I'm going to go by 0.1 here. If I go by tenths, Now I'm going to be able to see a little bit more clearly what's happening in my table. So I'm going to go back to the -2 section a little bit, and I'm going to see what's going on here. Definitely here I've got more accurate answers. Here I'm off by 0.4, here I'm off by 0.2, here I'm off by 0.05, and then right here I'm back to 0.01. So I know that my answer is somewhere in between here of -2.7 and -2.6. So if I wanted even more detail here where these would end up being the same, I would edit the table settings one more time. I could change it to maybe a 0.01, and now maybe I'd get a little bit more accuracy. So again, I'm trying to look for where the y values are the same as each other. I knew it was at about -2.6. So let's see if we can get down to the 2.66 region. Oh yeah, we're definitely getting into a region where they're definitely getting closer together. So I'd accept the answer here of -2.67 or -2.66 because they're so close to each other right there. So that would be the coordinate that you'd want to use. So let's go back to our notes now. So that's solving with a table. The rest of the video is just going to go through a few of the homework questions with students, including number 9, number 12, and a little bit of help with number 14. But the notes are officially done for this portion of the video. On this picture you can see that the system and the graph are already provided. It's pretty clear here that these two graphs cross two places, so there's two solutions. If I'm going to estimate where those solutions occur, this one down here looks like it's at about I guess I would say 0.9, maybe 0.8, and the y value is looking like it's about 1.8. And then I've got the other coordinate over here at about -2.4, and the y value is at 11. And so then they ask you to verify those solutions. You would take each coordinate and you'd plug it in for x and for y into each equation in the system. So you'd end up having to verify this 4 times. So I'm going to show you one of them. So for that first equation, the y value, I'm going to plug in the 1.8 because that's the y value. And then I'm going to use the 0.9 for the x value. And then I'd want to go ahead and calculate and see what I get there. So the 1.8 doesn't do anything. Over here when I type in 0.9 squared times 2 I get 1.62. Those aren't exactly the same, but remember I did estimate here, so I'm going to say that those are close enough. And then I would do the same thing with the second equation, and I would do it again with the next set of coordinates as well. So I'm going to leave students to finish our part C on their own. I want to help students just get started on number 12. This time the graph is not provided, and so students need to graph it themselves. Since this is going to turn into a parabola-shaped graph, I would graph this on the graphing calculator. There is a problem though with this particular equation. It's not set up right. I want to get it so that the y is alone. To get the y alone, I've got some options. I could either add y to both sides or I could add -x to both sides. I prefer to add y to both sides because then my y becomes a positive value, and that's what I think is easier to graph. So I'm going to add y to both sides. And now to get y alone, I would take away the 1. So I get x minus 1 equals y. So now that equation and this equation need to be graphed together. And then when students do that, they need to make a picture of that and estimate how many solutions by using the intersect command on their calculator. Finally, I want to help students with a little bit of number 14. In particular, choice A, or question A here, is something that they'll have to do on their next quiz. So I want to help students and make sure that they're clear on how to do that. It says that the family needs to hire a moving company. They call 2 different companies to get 2 different estimates of how much they'll be charged. Company 1 says they'll charge $1,000 plus 0.1 per pound, or 10 cents a pound. Company 2 says they charge less for their initial fee of $7.50, but they charge 2 or 20 cents per pound. So we're going to write a system that describes this situation. The first company charges $1,000 plus 0.1 per pound. Second company charges $7.50 plus 0.2 per pound. The only thing I would caution students about is to make sure that they have 2 equations, one for each company, put them together with a bracket, and then just watch out if you need to put this into your calculator, you'll want to use x as your variable and not the p. If you type it in with a p, it won't graph anything because it doesn't recognize that as your variable.